Unit 8 on classification, we started our unit talking about, what's this? These are my levels of language. Taxonomy. Which is basically how I group things. I go from least specific in my domain to most specific. So I start with 3 domains. I think you can see that. 3 domains, 6 kingdoms, and I work my way down to, I think we looked it up, it was 1.7 million species. We remember our levels. Dear King, please come over for good suit. Or Philip, whatever you want to call him. For good suit. Dear King Philip came over for good suit. He cooked a nice little meal for him. And so did your little species. Our last 2 categories, genus and species, play a role into our scientific name. That was our 2-word naming system. It's so you know who you're talking about. Whom. You know whom you're talking about. So, my genus are typically this category. My first word. And it is always capitalized. Capitalized. Species. My second word. It is always lowercase. Both of them will get italicized, both of them will get underlined. Basically, it's telling me, hey, this is who I'm talking about. This is what I want to talk about, or I want to reference. I'm going to go down next. You ready? James. Oh, yeah. Okay. So onto my classification. I'm going to zoom out a little bit so I can fit the whole chart on the screen. My classification of living things. Most of the unit focused on the fact that we have 3 domains: bacteria, archaea, and eukarya. Those 3 domains were basically broken into whether they were prokaryote or eukaryote. So this one's our eukaryote. Here's our pros. We said bacteria and archaea are a little bit different, so we did have to split them apart. So we did wind up with our 6 kingdoms. So your first kingdom is eubacteria. It is under the category of bacteria. I'm going to mark mine out. It is the only kingdom in the domain bacteria. Is it prokaryote or eukaryote? Prokaryote. Unicellular, multicellular. uni. How does it get nutrition? And it's autotrophic and heterotrophic. This is your normal bacteria. So that would be your E. coli or Streptococcus. Remember, that causes strep throat. Pneumonia is always a good one too. They love to give you. Archaeobacteria is the only one in the domain of archaea. They are prokaryote, eukaryote. Pro, unicellular, autotroph, and heterotroph. So how do I tell them apart? They live where? Extreme environments. That could be your thermophiles. Or your methanogens. And those are your only prokaryotic kingdoms. Your eukaryotic are protists, fungi, plant, and animal. The rest of them are all eukaryotes, meaning they have a true nucleus. True nucleus. So all of them are EU. Protists are mostly unicellular. They're believed to be the first eukaryotic organisms. But there are some multicellular protists, like algae. They can be autotrophic or heterotrophic. They're typically your weird group. If it doesn't fit into the fungi, plant, and animal, which are typically pretty strict, it's probably going to be a protist. We call it the catch-all group. So algae, amoebas, euglena, pretty common ones. Fungi, your funguses are always EU. They are mostly multicellular. There are some unicellular, like yeast. They are only hetero. These are your decomposers. They are all heterotrophic. Mushroom, yeast. Plants, EU, of course. They are only multicellular. They are only autotrophic. They make their own food. They are photosynthetic. Trees, grass, moss, bushes, etc. so on. And then lastly, animals are, of course, eukaryotic, multicellular, heterotrophic. Big thing about them, the way you can tell it's an animal and not a fungus, is because there is no cell wall. And they are mobile. For the most part, to be an animal, you have to be able to move. Those sponges, humans, worms, are all humans. To be an animal, you must be able to move at some point in your life. And they don't have cell wall. Protists, fungi, plants, archaeobacteria, and eubacteria all have cell walls. And that is your classification of living things. So we group them based on their cell type, how many cells they have, their nutrition, and where they live. Make sure you got them all. Ready? James? Okay, I'm going to pause it. Okay. Last part, bacteria versus virus. Right side. What do you know about bacteria? What do you know about viruses? Let me go back. What's virus do? What do you know about a virus? It has to use the cell to reproduce. Okay, that's it. They're not alive. I need a pen. So, bacteria are obviously living. Can you see that? Not really. What is going on with this pen? Let's try a different color. That one says no. Living, non-living. Okay. You said they need a host? Needs host. Do bacteria need hosts to reproduce? No, they do asexual repro. What else do you know about them? They're small. So bacteria are small, but viruses are super, super small. Are viruses made of cells? The prokaryotic cell. How do I treat bacteria? Antibiotics. Biotics. How do I treat viruses? Vaccines. What about both? What's common to both? What do bacteria and viruses both have inside them? DNA, genetic material. And they both cause disease. And last thing I put was microscopic. Microscopic. And then right under that, it gives you some examples of viruses and bacteria. They love to ask you common examples. So you do need to know things like the cold, the flu, and COVID are a virus. And ones they love to give you: strep throat, streptococcus, pneumonia, and E. coli always pops up too. Or bacteria. They love to ask you that. UTIs are bacterial. Food poisoning, salmonella might pop up, but E. coli is always a big one that they pop up. last section. Germ theory. What is the germ theory? Microorganisms cause disease, right? Which experiment is this one? What's the name? Do you remember? Important guy. He probably does things to your milk. He's the reason things get done to your milk every day. Not ready. Pasteur. Pasteurization is still used today. So he did his little bottleneck experiment. He boiled a flask, kept it stable, left a little bottleneck, nothing got into it. The moment he took away that neck, he got bacteria into it. Or if he tilted the water, bacteria got into it, which meant the bacteria were hiding right here in this little part of the flask. So there are microorganisms in the air, and microorganisms cause disease. In air. He disproved spontaneous generation. Spontaneous generation. And that was kind of the end of Unit 8.